You know what the 2 is? What's the 2? Here, I'll help you out.
That's the rise, right?
Yeah, you're right. It is the rise. It's part of the slope, right? But we don't want to start with the slope. We need to start with a point. So what's a point we know is on this line?
Oh, the y-intercept?
Yeah, what is the y-intercept?
Positive 1.
Yeah, so I'm going to go right here, okay? There's my point. There's my first point. Right there, okay? Now, Chenier, where am I going to go from here? If I know my rise is 2, what is my run? Remember I did this before? I went like this when I was asking Rudy why it was rise over run, and I took the 2 and I put it over 1. Do you remember that?
Yeah.
Okay. So in this case here, if I'm starting here, what is my rise? 2. And what's my run?
1.
Good. So I'm going to rise 2, 1, 2, and run 1. So it's this point and this point that I have to go through. I'm trying to do them perfect. Perfect. Booyah. Looking good. All right. Keep going, Chenier. So now we have to deal with this 0.5. It's kind of ugly like that, right? So why don't we write that 0.5 like this? Would you agree? 0.5, negative 0.5 is the same as negative 1 over 2?
Yes, sir.
Okay. So where am I going to start?
Negative 4.
Good. Negative 4 here. Okay. And what am I going to do? Rise what and run what? Now you can choose where you deal with that negative, but you can't put it on both. So you choose if you want to rise or you want to lower it down or run right or run left. You tell me. I'm right here.
Let's go down 2.
Down 2? Okay. You're going down 2. That's not going to work. Okay. Although you can put the negative wherever you want, you can't rise differently than 1. So you're either going to go up 1 or down 1, right? Because rise is 1.
Alright, so yeah, go down 1.
Okay, down 1 and
And then run 2.
to the right or left?
Left. That's negative, right?
That's negative. Yeah, but you've already gone down negative. So that was the one thing I said you can't do. You can't apply the negative sign to both the numerator and the denominator.
Go right.
Yes, down 1 and then run 2. Everyone understand that? Any questions there? Here's my other point. Please ask questions now, because we're getting to the end of this. Nope, missed. There's my 2 lines. You have a question?
Yeah, I was just asking what you did, like what's the points, because I can't really see.
Yeah, I'm gonna say, see this point here? Like we're gonna call it this point here. We're gonna say that this point is negative 1, 2, and negative 1, 2, 3. So negative 2, negative 3. That's what we're gonna call that point. Negative 2, negative 3. It's very close to that on the graph. Let's just double check. We can just check one of the lines, make sure if we know it's on that line, we're probably pretty sure it's on the other. So let's go negative 2 in for x becomes negative 4 plus 1. Y becomes negative 3. So it works. Right? Negative 3 in for y. This becomes negative 3. Yeah, it works. Yep.
I know you haven't like. Oh wait, are you able to like show us how we can solve with substitution? Because I don't know what I'm.
Yeah, we'll do substitution. You're going a bit ahead here because I'm still going to teach you substitution, but I like it. It's a switch up. We're going ahead, not going behind. So let's do it. Ethan wants to know substitution. So what I'm going to do is I'm going to sub in one y for the other. So I'm going to say 2x plus 1 is equal to negative 0.5x minus 4. Right? You understand what I did? Okay, so now I need to solve for x. So I'm going to bring the x's to the left. I have 2x plus 0.5x equals negative 4 minus 1. Now I have 2.5x equals negative 5. Now I have negative 2. If x is negative 2, I can sub it into either of the equations. Let's sub it into this one, just because we're not dealing with the decimal. So we get 2, negative 2, plus 1, negative 4, plus 1 equals negative 3. My point of intersection is therefore 2, negative 3. See how fast? See how easy it is if you know grade 9 substitution distributive property? Fast, quick things. If you don't, there's going to be all kinds of trouble here. All kinds of trouble. That's the worst part about this. You're going to know exactly what to do, but you can't do it. You got to go back and learn your grade 9. You got to know how to move this stuff around. Okay? You got to understand that I divided both sides here by 2.5. I can't keep explaining this. You just got to look at it and know. Okay, you good with that, Ethan? We'll move on? All right. This one Douglas is going to help us with. Let's go, Douglas. Let's do this quick. The first one, y equals negative 5. What's that look like?
Negative 5 over 1.
No. You're talking about the rise and run?
Yeah.
No. That's just y equals negative 5. That's a specific type of line.
Oh, so it's vertical?
No. What's the other one? Not vertical?
Or horizontal?
Yeah, it's horizontal, right? We know it's horizontal because y equals negative 5. That's here. This is negative 5. All of these values here along this line, all of this line is y equals negative 5. Does that make sense to everybody?
Yeah.
So when you have y equals a number, that's a horizontal line. When you have x equals a number for the slope, that's a vertical line. Okay? And we know that also, right? Because if we think about the equation of the line, it's y equals mx plus b. Well, if it's a horizontal line, the slope is what, RC? What's the slope of a horizontal line? Of any horizontal line, what's the slope? I said it way back here. You guys remember? Here I talked about. Yeah, I talked about it right here. Good, 0, right? Okay. And why is it 0? Do you know why it's 0? Yeah. Because what?
Is it because it's the x? Something to do with x?
No. It's because the equation for a line is rise over run. And if you're not rising, it's 0. Right? If it's 0 over anything, it's 0. So you actually know it's 0x plus b, and then so you get, with 0, the x cancels out, and you just end up with b here, y equals b. So when you have a horizontal line, the formula is y equals the y-intercept. That's it. Make sense? All right, Douglas, keep going. We're going to graph this one now. More traditional, looks a little better. So where am I going to start, Douglas?
Negative 3.
No, where do I start when I'm graphing a line? I want to start with a point, right? What point should I use here?
Over to 1.
Yeah, what point? Tell me. Tell me.
Negative 3.
Negative 3? No, that's the slope. I want to start with a point.
So I'm confused.
Okay. Look at this equation right here, okay?
Yeah.
What is one point on this line that you know right away?
Positive 1.
Positive 1 what? You're right. Positive 1 is the y-intercept, right?
Yeah.
You know that, right? Because that's the y-intercept right there. Okay? So it's positive 1. Good. Now, what am I going to rise and what am I going to run?
You're going to rise 3.
I'm going to rise 3. Okay. If I rise 3, 1, 2, 3. What am I going to run?
1.
Which way?
Right.
Wrong. Not right. Why is that wrong? You didn't take into consideration the negative sign here, Douglas, right? This is my slope, right? My slope, Douglas, is negative 3, okay? We know that's also negative 3 over 1. Same thing. So you're...
So it's both negative?
Yeah, you're either going to lower negative. Let's just always put the negative on the numerator. We good with that?
Yeah.
So we're not confusing anybody. Always put it on the numerator, okay? So if it's negative, you're never going to rise. You're going to lower, okay? So in this case, I'm at 1, 0. I'm going to lower how many? Douglas.
3.
1, 2, 1, 2, 3. And I'm going to run how many?
1.
1. Okay. Here we go. Oh, perfect. Perfect. I don't even have to check this one. Check that out. Right on. Right on. What's the point here, Milkius? What's the point?
2, 5. 2, 5.
Nope. 2 I like.
Oh, 2 minus 5.
Yeah.
So hard.
I got that one perfect. Any questions? All right. Oh, we got one more page. Thought I was done. All right. It's going so slow. I want to go quick here. Lucas, come on. Help me with this one quick, please. Where am I going to start? Positive 7. Good. Lucas, then? What am I going to do? Sorry? 2 down? Yeah, 2 up and 1 to the right. Good, it's up here. That's a little unfortunate, but it is what it is. That's our line. It happens. Happens to the best of us. We make our graphs too small. Deal with the consequence. All right. Okay. There's my graph, plus 7. I go 2 up, 1, 2. I go 1 over. Perfect. Now, SpaghettiOs. What do we do with that? I don't like that. We don't like that. It ain't in nice graph linear form. What do we do, Lucas? Swap the y? Y equals 2x. Yeah? Keep going. Minus 2. That's it. I just had to rearrange it. Why was it that easy? Just because when the y moves over the equal sign here, it became positive. Okay? I did switch it. It would have actually looked like this, right? But you can put that y wherever you want, on the right or the left. I hope that doesn't confuse anybody. Anyone confused there? All right, if that's my second line, then keep going, Lucas. Where am I going to start? Good. Yep. And what do I do? Yep. Good. Oh no. Oh no. This ain't looking good at all. Ah, I didn't draw it great. Let's see if I can draw it. Ah, good enough. Good enough. Okay. Good enough. What do we got going on here? Now this was not actually drawn perfect. It should have been like this. Ah. Now I'm drawing this again so that I can really demonstrate this to you. All right. What is going on here? Alan, tell us what's going on here with this one. What's the point of intersection? Sorry? Nothing. None. There is not one. Why not? Yeah, the lines are parallel. How do I know the lines are parallel without graphing it? Yeah.
They have the same slope.
Yeah, they have the same slope. If the slope is the same, we know they're parallel, right? Because the slope is telling us the angle of the line. So in this case, after we arrange this equation, right away we should have knew something was up because the slope was 2 in both scenarios. So we know the slope is the same, they do not intersect. There's no point of intersection. All right? Questions? Yep. Who said sir?
I just say yes, sir.
Oh, okay. Okay, Josiah, you're going to do this one. What's the first step I'm going to do with this equation? I'm going to find the slope. Okay, but it's not in the right format. So can you help me rearrange it?
Isn't the y equals negative 2 over 3?
Yeah, this one is okay, but I'm talking about this one here. The one above. Can you see it?
Yeah.
Okay, so how do I rearrange that?
You need the t and x
Yeah, so tell me what to write.
I don't know what to write. I just know you have to move it.
All right, well, you would write something, right? So what would you start writing here? -6, okay.
Equals 0. Plus negative 2y. I mean negative 2x.
Okay. Now what?
Minus negative 2y.
Okay. Now what?
And then put y over 1, so like put the x over 3. I mean, yeah, the x over 3.
X over the 3. Like x over 3? All right. Okay, Josiah, you really gotta pay attention here, okay? Because if you can't rearrange this formula, you have no chance. You can't solve the problem. You can have no chance. You gotta listen, okay? You gotta practice this. Jeds, can you help me arrange this?
So I take out the 3 lines over the equal sign, so negative 3y
Okay.
equals 2x plus 6. No, minus 6, sorry.
Okay. Now what?
Now I can do this. Equation of that line.
Sorry?
That is
No, that's not the equation of the line. That looks mad ugly to me. Yeah. You gonna do it right?
Yeah.
Guys, this is why I'm so frustrated. Because if you can't do that, I can't teach you anything. If you can't arrange this simple equation, I can't, like, I'm handcuffed. Like, how many people feel comfortable moving this into y equals mx plus b? I can't keep teaching this. Okay, it's great. I think you can, right? But I gotta check. Milkius, can you move this around? Let's see. What do you got, Milkius? Josiah, can you do it?
I put y equals 2x plus 3.
Y equals 2x plus 3? That one looks good? Incorrect. No, not close. Not really close. Go ahead, Shanir.
I can put y equals.
Sorry?
Plus 3.
Plus 3? Oh man, this is brutal. Jaden, can you do it?
Y equals 2x plus 3y minus 6.
2x what?
Plus 3y minus 6.
Okay, now what? You've added you've separated y's now. Now you're in all sorts of trouble.
Hold on, is it 3y equals
3y, I like that better, equals.
2? Take out the 2 and then minus 6.
Oh, you're close, but no cigar. You're getting closer. Oh, Rudy, let's go, Rudy, let's go.
Okay, so do 3y equals,
Yeah,
and then the 2x turns negative,
yeah.
and then it would be positive 6.
Hey, my man. So keep going. You're not done though.
And then you would do 3y equals,
3y, we already have 3y.
yeah, so you would do negative 2 plus 6.
Oh, he got the first step.
Yay.
RC, can you finish it off? No?
Oh, wait. So that would be
Yeah.
positive 4x.
Positive 4x. 3y equals positive 4x?
Then when you divide,
Nope.
so then divide.
Can't combine the negative 2 and the 6 because they're not common. They're not like terms. Grade 9. They're not like terms. You cannot combine them. Yep.
Wouldn't you plot it?
Nope. I need y equals mx plus b. Guys, if we can't do this, if we cannot do this, we cannot learn grade 10. We can't. So either go home and learn how to do some basic algebra and gather like terms. It's going to be so frustrating for you guys. You can't answer the problem. All I'm doing is rearranging. And I can't teach this every time. Alan, can you do it? No rise over run yet because we don't have it in the right formula. We don't have it in the right... We need y equals mx plus b. That's what we need before we can start. Yeah. Yeah, divide by what? Good. Okay, I'm dividing this by 3. What am I doing to this side? Oh, you said 4. You had a 4.
Yeah, I was gonna see that next divide.
Well, you can't do that if you have a 4. You can't, because it's wrong. So I stopped you. Divide this by 3, right? Yeah? Okay, now what? What do I get on this side? What? Okay, good. Y equals. We're getting there. Now what? Six turns into a 2. Okay, I agree. What goes there? Negative 0.6? Negative 0.6? Nope, nope. Stefan, can you do it?
Negative 1.
Nope. RC. Negative 2 over 3 plus what?
Plus 2x.
Okay, you're just missing one thing. Very close. Yeah, good job, RC. So you did that last part, but you missed the X. Yay! We there. We made it. We made it. We're here. Guys, you gotta learn how to do that if you cannot do that. Google 2x plus 3y minus 6 equals 0. How do I solve this? You'll have 10,000 different results showing you how to figure that out. I can't take 20 minutes every time I have something like this and explain it every time. I'm just gonna fly by and I'm gonna feel bad. But it's just gonna be 50% of the class I'm gonna lose every time. You gotta learn how to do that if you wanna stay in this class. I almost feel like if I have this tomorrow and you can't solve it, no, it's gonna come up 1,000 times in this course. Little stuff like that, it's gonna come up all the time. Okay, I want to really finish, so I'm gonna fly to try to finish this. So here are my two equations, right? I'm gonna start with this one because it was on the top. So I have my y-intercept is equal to 2. I have, here is my slope, negative 2 over 3. So we're gonna deal with the negative sign on the numerator. So I'm gonna go down 2, 1, 2, and I'm gonna run 3, 1, 2, 3. So my 2 points are here and here. Okay, so I'm gonna graph that. That's my first line. Okay, next line, I'm gonna start at plus 2 because that's my y-intercept. I'm gonna go down 2 because it's negative 2 again, 1, 2. And then I'm gonna go over 3, 1, 2, 3. Here's my point again, right there. So, that the same slope again? Oh my God, it's the same line. Oh my God, the 2 points are the same. It's the same line. What a dirty question. Literally gave us the same line, but one was just changed.
Shows us the cases at the back.
Sorry?
It tells you like the different type of intersections in the back page.
Yeah, case 3. Yeah, it gave us the same line. Sorry, guys. So the point of intersection here is infinite because it's intersecting everywhere, along every point. Okay, that was a twist. I wasn't expecting that. All right, key concepts. When you're solving systems, you're graphing, finding intersections of lines. For two variable systems, there are then 3 possible types of solution. Case 1, case 2, and case 3. So either they intersect properly, they're parallel, or they're the exact same line. All right? Those are the 3 cases. Case 1 shows 2 distinct non-parallel lines that cross at exactly 1 point. They're called independent systems of equations. So if I ask this on a quiz, I ask you, what is an independent system of equation? Adrian?
Some where 2 different lines get to exactly 1 point.
Yes, perfect. If I ask you, what is an inconsistent system of equations? Case number 2, RC. What is an inconsistent system of equations? 2 lines that are parallel. Perfect. And if I ask you, what is a dependent system or a solution, and the solution is a whole line? Okay, that is a dependent system. So case 3, dependent. Case 2, inconsistent. And case 1 is independent. Independent, inconsistent, dependent. Okay? This shows that a system of equations may have one solution, that's if it's independent, no solution at all, or an infinite solution when it's the same line. You'll never have a system with 2 or 3 solutions. It will always be 1, none, or infinity. Any questions? All right.